Most big galaxies contain big black holes. Not just big, supersized, with millions of times the Sun's mass. Some of these black holes are actively devouring gas. This drives particle jets that can spew matter millions of light years into space, and it also makes the holes a source of penetrating, or hard, X-rays. At these energies, the sky glows in every direction, even far away from bright sources. Astronomers have long suspected that active supermassive black holes in galaxies were responsible, but they just couldn't find enough of them to account for the X-ray glow, especially the peak of the energy spectrum. Now, astronomers using NASA's SWIFT satellite confirm that a largely unseen population of black hole-powered galaxies is out there. There are so many that scientists say they might fully account for the cosmic X-ray background. What emission we detect from an active black hole is a function of how we see it, whether we're looking face-on and into one of its jets, or viewing it from the side through the disk of gas and dust that surrounds it. The brightest active black holes, which include quasars and blazars, are those we see face-on. But as the viewing angle increases, the surrounding disk absorbs increasing amounts of radiation. Astronomers have always assumed that many active galaxies were oriented edgewise to us, but because the disk of gas smothers most of their X-rays, these sideways black holes just weren't detected. And that's where SWIFT comes in. Since 2004, the satellite's Burst Alert telescope has been building up the largest, most sensitive X-ray map of the sky. Using these data, astronomers found that the most heavily absorbed galaxies create the energy peak in the cosmic X-ray background. What does it all mean? When the universe was about half its present age, about 7 billion years ago, galaxies crashed together more frequently, and these collisions produced gas-rich galaxies with heavily obscured black holes. The SWIFT survey shows that galaxy mergers helped activate these black holes by feeding them torrents of fresh gas. The new findings are consistent with the idea that the X-ray background peaked around this time, when our own galaxy was young and before our solar system was born.